A current-carrying wire produces a magnetic field in the region around the wire. When current flows in a wire wound round a soft iron core, an electromagnet is produced. We have just seen that electricity can produce magnetic effects or magnetism. Can magnetism produce electricity? Look at the galvanometer. What happens to the galvanometer pointer when the wire moves up and down across the magnetic field? The galvanometer pointer shows a deflection to the right when the wire moves down and a deflection in the opposite direction, that is, to the left, when the wire moves up. What does the deflection of the galvanometer pointer indicate? The deflection of the galvanometer pointer indicates that there is a current flow. As the wire moves up and down, the magnetic field lines or magnetic flux are being cut. As the magnetic fluxes are being cut, an EMF is induced across the wire. This is known as electromagnetic induction. The induced EMF will cause a current to flow in the wire. This current is called the induced current. What happens to the galvanometer pointer when the wire is stationary in the magnetic field? The galvanometer pointer does not show any deflection, indicating that there is no current flow. Why? The magnetic flux is not being cut by the wire. Thus, no EMF is induced. Hence, there is no flow of induced current. What do you think may happen to the galvanometer pointer when the wire moves parallel to the magnetic field? The galvanometer pointer does not show any deflection, indicating that there is no current flow. Why? When the wire moves parallel to the magnetic field, no magnetic flux is being cut, no EMF is induced, thus there is no induced current flowing in the circuit. What will happen to the galvanometer pointer if the wire is made stationary, but the magnets are moved upwards and downwards as shown? The galvanometer pointer shows a deflection to the right when the magnets move upwards and a deflection in the opposite direction, that is, to the left, when the magnets move downwards. Why? As the magnets move up and down, the magnetic flux is being cut by the wire. An EMF will be induced across the wire and cause an induced current to flow. An EMF is induced across a conductor when the magnetic flux is being cut by the conductor. This is known as electromagnetic induction. The induced EMF will cause an induced current to flow in a complete circuit.